All right, so I did a quick calorimetry lab. I have a 10.492 gram soda can that's empty, and then I put some water in it. And after that, it measures as 25.592 grams. So that was about 15 mils of water. And then here's the peanut butter Captain Crunch, which is zero point 0.4 grams. And here's some tinfoil. I don't know that it's worth figuring out, but it's there. So the can is going to start at 19.2 degrees Celsius, and I am going to light the Cocoa Puff on fire right here. And then the idea is that the energy from the Cocoa Puff, or I'm sorry, from the Captain Crunch is going to go in the can and the water and heat all that up. And the amount of heat from the cereal will go into the can and the water. So if we calculate how much heat was in the can and the water, we'll know how much heat was in the Cocoa Puff. So as you see here, it gets burning and it's heating up the can. So it was 19.2 degrees, and you can see it's already up to 35, 36, 37 degrees. So the temperature is going up, and I sort of zoom in so you can see that it's on fire. So there it is on fire. And then it gets up to about 44, I think 44.0 is as high as it goes. And then it just starts going back down. So what we have there, and then it's all burned out. All right. So what we have going on there, now check this thing out. Look at this. This was just suggested to me. Look at that. How cool is that? Anyway, I don't even know what that is. It's probably like dishwashing. So this is hideous, but I had to show you because of that other thing. All right, so we had peanut butter Captain Crunch, and it was burned. The can was 10.492 grams. So we have the aluminum can is 10.492 grams, and the specific heat of aluminum is 0.798 joules per gram degree Celsius. Wait, oops, that's not true. It's actually 0.897, I think. 0.897. All right. And now our change in temperature, right, was the difference between 19.2 and 44, which is 24.8. So 44.0 minus 19.2 gives us 24.8 degrees Celsius. So that's our delta T. All right, so that was the aluminum. The water absorbed some energy as well. That water weighed 15.1 grams. That's how much water there was. The specific heat of water is 4.184 joules per grams degrees Celsius, and then the same delta T was 24.8 as well. So to figure out all the heat lost by the Captain Crunch, so if we're going to do this, let's do yellow. So the heat lost by the Captain Crunch would equal the heat gained by the aluminum, right? The heat of the aluminum plus the heat of the water. So if we can figure out the heat of the water and the heat of the aluminum, we can figure out how much heat was lost by the Captain Crunch. So the heat of the aluminum is going to be um, the mass times the specific heat times the delta T. And then we're going to add to that the heat of the water. So that's 15.1 grams times the specific heat times the delta T of the water as well. So we're going to assume that they're in equilibrium and everything was cool like that. So the heat gained by the can is 10.492 times 0.897 times 24.8. So that's 233.4. It's 233.4 joules. And then the water is 15.1 times 4.184 times 24.8, which is 1567. So the total heat was 233.4. So yeah, so 1800. So that was 1800 joules released by the Captain Crunch. All right, so that's how you do that. And then I did another one. So on the second one, if we're going to watch that, I did some Fruit Loops. So there's the mass of the Fruit Loops, which we didn't use the mass of the Captain Crunch, but we can talk about that later. It's the same can, so 10.492. After I put water in it, it is, so I put a little more water this time. I tried to go for about 20, so 30.660. So you figure out how much water is in there. And then it starts at 19.4 degrees Celsius. And after heating up the two Fruit Loops, which I believe is a green and red one, I don't know if their flavors are any different. Look at this one, though. This one catches right on fire. Look at that go. So that goes up to a temperature of, yeah, you can see this burning. Look how well that's burning up. Look at that go. Fruit Loops. All right, so that aluminum there was a gram, if you want to figure that out. So this gets up, because it's only 20 mil, it's a little more water, so 20 mils, it gets up to, let's see what it gets up to. It gets all the way up to 35.6, I'm going to bet. I think it starts going down. There it goes. So 35.6 was the max, and then it started at, where did it start? Let's get back to where it started. It started at 19.4. So 19.4, 35.6. Do some math to figure out the mass of the water. The can is the same. And so the mass of the water is 30.66. 30.66 minus the can, which is 10.492. So we use 20.168 or 20.17 grams of water. And you should be able to figure that out for the Fruit Loops.